In the last video, we saw some simple ways to define JavaScript numbers in our programs. Now we'll take a look at a few more advanced techniques for creating numbers. So we've seen how to create numbers using different literals in JavaScript. We've created whole numbers, floating point numbers, and negative numbers, and we've seen the different rounding errors that can result from doing operations on our floating point numbers. There are a couple of other ways that we can create numbers in our JavaScript files. One way we can do this is using a different type of literal for our JavaScript numbers. And this one is useful for instance, very large numbers. Say we wanted to represent the number 1 million. Well, one way we could do that is by typing in, let's say, g equals 1 with 6 zeros after it. So 0, 0, 0, 0, 0, 0. And if we go into our browser, refresh the page, and take a look at our variable g, we'll see that it's 1 million. But this isn't a very great way to represent our number. There's a lot of zeros next to each other, and we have to really get in there and count to figure out what the number is. Instead, we can use an exponential representation of this number. Instead of thinking of it as 1 with 6 zeros after it, we could think of it in scientific notation as 1 times 10 to the 6th power. 10 to the 6th power is 1 million, but that's how we would represent it. So how we can do this instead of having our 6 zeros at the end is we'll do 1, e, and then the number 6 for the 6th power. And if we go back to our browser and refresh our page and type in the letter G, we can see the number is also 1 million. Now we don't have to just have the number 1 before our e here. We could do 1.23, and that would be 1.23 times 10 to the 6th power. So it'd be 1,230,000, hopefully. So if we save it out and refresh, and now if we type G, we can see you get 1, 2, 3 with 4 zeros after it. So this allows us to create very large numbers without creating very large JavaScript literals in our code. So we could extend this out even to the 16th power. And if we refresh and take a look at G, we can see we have a very large number that we didn't have to manually type out. So it's both easier to read and less error prone in our JavaScript code. Now here's a curious example. Let's take the variable h, and I'm going to use the literal 0, 1, 2. Now if you look at this code, you might assume that its value is the number 12, or 1 dozen. But if we go back to our code, and remember this is a variable called h, and we refresh, we see when we type in h, the number is 10. Now, why would this be? Well, because our JavaScript literal began with the number 0, it actually is being interpreted as an octal number. So what does this mean? Well, normally, when we think about numbers, we think about it in the decimal system, meaning it's base 10. So we use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when we go above that, we use the next digit to the left, put a 1, and start back at 0. So each place in our number represents a power of 10. However, in octal, each place in our number represents a power of 8. So instead of using the numbers 0 through 9, instead we use the numbers 0 through 7. And then when we go to the number above 7, instead of representing it with the digit 8, we instead move to the left, set its value up 1, and then use a 0. So instead of going 6, 7, 8, in octal, you would go 6, 7, 1, 0, or 10, even though 1, 0 would actually be the representation of 8 in octal. So when we see 0, 1, 2, we're seeing octal, and we can calculate its number. By seeing the 1 in the second to last place, we can see that means 8, and then in the last place we see 2, so we can add 8 plus 2, and its actual value number is 10. Now, using octal numbers isn't something that you would do very often in code. However, this mistake can show up in your code and be very, very confusing. You'll wonder why you typed in one number and it seems to be representing a different one. Well, that's just because the 0 puts it in a different base. So the resolution to this issue is to not lead your JavaScript numbers with a 0, because that has a very specific meaning which will cause a lot of confusion. So here's another issue with octal. 0, 1, 2 here is being read as an octal number representing the number 10. However, if we change the digits from 0, 1, 2 to 0, 1, 9, what would happen? Well, because we're starting with a 0, we think we're in octal. However, because the number 9 is not used in octal notation, because the highest digit we can use is 7, then we would have a problem. You would hope that this would have some sort of error, but instead, if we go back to our code and check the value of h now, it's 19. So again, we see starting with a 0, we think it's octal. However, we see an illegal octal character, so JavaScript interprets it as a decimal literal 19. So it's very confusing. So the moral of this is do not lead your JavaScript literals with 0 because it will lead to some very confusing results. Now we've seen that JavaScript can handle literals in both decimal and octal notation, which we've seen here. Now there's actually one more base that JavaScript can handle number literals for, and that's hexadecimal. Now hexadecimal numbers are base 16. Now you may have seen hexadecimal numbers, for instance, when working with colors in CSS. For instance, when you represent red, the number you would use is FF0000. Now this is actually a number, but it's a base 16 number. And you can think about the color red split up like this. The first 2 digits represent a number that represents the red value. The next 2 digits would have been the green value, and the next 2 digits would have been the blue value. So FF actually represents a number, in this case 255. But we can actually represent this in our JavaScript literal. The way we do this is we'll create our variable I here, and we'll lead it with a 0, but also lead it with a lowercase x. And the 0x represents that we're going to have our literal be in hexadecimal notation. And this means our characters can be not just 0 through 9, but also A through F. So if we typed in FF and we check the value of I, we see the number is 255. So by changing these numbers around, we can do F0 and see that I is 240. And if we wanted to just see what the value of F would be, we can refresh, check our value of I, and see F represents the number 15. When you add 1 to that, it would become 16, and 16, when represented in hexadecimal, is 10, because that's the base of hexadecimal. So if we save this and refresh, 0x10 should represent 16. Now this could be useful. You don't use it very often, but sometimes you do want to represent a number in hexadecimal form, so if you ever do, this is a way that you can do it. So now we've seen all the different ways that we can define numbers in JavaScript. Up next, we'll see some of the things that we can do with those numbers.